In this video, we discuss the derivatives of exponential functions other than e to the x, so that you'll be able to find the derivatives of, well, anything raised to the x power. And we will illustrate this with an example and use that example to establish a general rule about evaluating things raised to the power x. So in our example, we're given the function 10 raised to the power of x and asked to find its derivative. To evaluate this derivative, we use a little trick to place the function into a more workable form. So we use the property that any number can be rewritten as the natural log of that number, and we take that result, say ln a, and we place it as the exponent of the base e, where we have e to the ln a. And a good way to understand that is it's the exponential version of adding and subtracting the same number or multiplying and dividing the same number. You're just performing an operation and undoing it with the associated inverse operation to end up with the same number that you started with. So in this case, we use it to rewrite our function as e raised to the power of ln of 10 raised to the power of x. And from there, we appeal to the rule of logs to bring this x down. So we take the x and we bring it down, and we end up with e raised to the quantity of x times ln 10. And we recognize that we have a composite function here where we have e raised to the power of some function, and that inner function is x times ln 10. And we use this fact in the chain rule to evaluate the derivative. So we have the derivative of the outside function, which is just the same thing over again, e to the x times ln 10 times the derivative of x times ln 10, which the derivative of that is just ln 10, a constant. And so next we place the x back in the exponent slot, and then we just simply rewrite the number in the form 10 to the x times ln 10, and that's our final result. That's our final answer, and we've arrived at the general rule, which states that if we were given any number, in this case we call it a, and we raise it to the power x, and we take the derivative of it, well, that's just a to the x, but only the only difference is that you multiply it by ln of a. And note that this is only valid for a's greater than 0. And that concludes this portion.